All right, we are going to get this started on time, just as promised for you guys. So good afternoon, everyone, and a good early morning to our Australian friends joining us. Thank you all so much for joining us today. My name is Nicole Baker. I'm the Sales and Customer Training Manager here at HexArmor. Today we're going to do a little bit of teaching on the recently published ANSI ISEA 138 Impact Resistance Standards. But before we get started, I want to cover a few housekeeping notes for you guys. The webinar has been recorded and it's going to be available for you guys after this session. 2, I have all of the attendees on mute to keep the audio clean and clear for everyone so we don't have any feedback from you guys. 3, I appreciate all of the questions that you guys submitted upon registration. I'm going to work to get those questions answered throughout the webinar, as well as I will answer questions at the end. Feel free to, at any time, drop a question into either the question field or the chat box. And if I don't catch it right away, we'll make sure and get those answered for you at the end when I have an open time for you. The last thing that I will note is that there is a handout on this webinar attached. So you can download it right now if you'd like, or after the webinar. It will also be emailed in a follow-up session to you guys. So no worries if you don't get to it right now or you're calling in. So without further ado, let's get started. As I mentioned, I'm only going to spend the next hopefully 10 to 15 minutes kind of covering all of these topics. I'm going to introduce to you the EN 388 Impact Standard. It's the first of its kind. Then we're going to dive into the ANSI ISEA 138 Impact Standard, which was published earlier this year. So why was there a need to even introduce the additional impact standard? Well, hand injuries make up the second highest incident rate, and they cost on average between $6,000 and $7,500 per claim. Those costs often exceed the cost of providing the proper levels of hand protection. So let's help you identify what those proper levels are. The chart that you guys see in front of you, it's going to outline the 2 different organizations and subsequent standards and tests that we're going to discuss today. So to start with the EN 388 Impact Standard. One thing to know, impact standards have been around for nearly a decade, but this standard, which was an industry first, wasn't published until 2017. The CE test was actually adapted from an existing standard for motorcycle PPE, which is why it has its nickname, the motorcycle test. Because it came from a pre-existing test, there are some limitations to it. Like it only tests the knuckle region, and it's being reported as either a pass or fail. So in the EN 388 test, the glove is cut in half, so only the material on the top of hand is being tested. And then there's a 2.5 kilogram striker that's dropped 20 centimeters, which is roughly 5.5 pounds, dropping 8 inches to strike the glove material. The machine measures the amount of force that transfers through the glove material. So with nothing on the machine, the force measures around 20 kilonewtons. In order to pass the EN 388 standard, the glove materials must reduce the transferred force by 65%, registering less than 7 kilonewtons, or an average of 9 kilonewtons. So you're going to see this noted as a pass or fail in the 6th entry on the EN 388 symbol. So if you are able to see my screen, it is in the upper right-hand corner. That is the EN 388 symbol or shield. It may also be noted, or you may be more familiar with it, called the CE score. So it's going to be that 6-digit over. A P for pass, F for fail, and X is either is not tested, or there just may not be a digit there. So as soon as CE published the EN 388 Impact Standard, the ANSI ISEA assembled a group of 25 manufacturers that started to outline their own impact standard. As you saw published in February this year, ANSI ISEA finally launched this upgraded standard. Excuse me. So while they still use the same machine and the same basic test elements, ANSI ISEA calls for modifications to the previous method. The glove is still cut in half, so only the back of hand material is tested. And the striker is still 2.5 kilograms, dropped 20 centimeters. Again, you're looking at roughly 5.5 pounds, dropping 8 inches. However, the ANSI ISEA 138 impact standard calls for both the knuckles and the fingers to be tested. So all in all, there's 18 areas being tested. It also provides results on a 1 to 3 scale instead of that pass-fail. And the levels are going to be noted on the packaging and spec sheets with a hammer striking the hand icon, followed by a 1, 2, or 3. So again, if you can see my screen, that's going to be in the lower left-hand corner. You can see the hammer striking the hand, followed by that 1, 2, or 3. That is how you're going to identify the levels for the ANSI ISEA. I want to show you guys quickly what the test actually looks like. We're lucky enough to have a demonstration machine here at HexArmor, but unlike other ANSI ISEA standards, this impact standard is the first to require third-party testing. And what that third-party testing does is it just ensures accuracy across the industry. So as you can see in the video, there's that 5.5 pounds, dropping that 8 inches. It may not look like a lot, but I certainly wouldn't want my hand underneath that. So to give you guys a real life example of how important the upgrades are to the ANSI ISEA test compared to the EN388, this is our 4021X. It's a real beefcake of a glove. It looks like it has a lot of impact protection, and it does. However, it still only scores an ANSI ISEA level 2. Let me show you why. If you separate out the scores, that glove, the 4021X that you just saw, scores as a level 3 on the back of hand. That's the only area that the EN388 tests. So it scores at the very highest level for the back of hand. However, it scores a level 2, a lower level, on the knuckles. It's really important to note because most of the breaks are occurring and those impacts are occurring on the fingers and not the back of hand. So there's a lower level reported as an overall score on the fingers, and that's where most of these breaks are happening. So for visual sake, I want to show you what a level 1, 2, and 3 can look like. So I don't want you to just assume that if it looks like it offers more protection, that it actually does offer more protection. You want to be cognizant of what materials are in that glove providing the impact protection. You can get that from the manufacturer. And then you also want to look for the symbol. So whether you're looking for that pass or fail on the EN388, or you're looking for that level 1, 2, or 3, again, the symbols, if you can see my screen, are underneath the gloves, 1, 2, or 3 for the ANSI ISEA 138. I also want to show this chart to you guys. So the test results for both the EN388 and the ANSI 138 are going to be reported in newtons of force transferred through the glove material to the machine. So similar to golf, the lower the score, the better. Reporting this way shows what got through the material, but you can expect that marketing is going to start to show the opposite. Marketing is going to show how the glove material actually performed. So this graph is a great visual for that. It's going to be showcased as percent of energy absorbed, aka not entering the hand. So to pass a level 1, 55% of the force must be absorbed by the impact material. To pass a level 2, 67.5% must be absorbed. And to pass a level 3, 80% of that force must be absorbed by the glove so that it does not get to the hand. Last thing I want to remind you guys is that this is done in a lab. It's a lab test, which is a great way to establish a hierarchy of performance results, but it's not done in real life scenarios. So although ANSI ISEA, that group of 25 manufacturers, did work with universities to try and determine the amount of force to break a bone, there ultimately were too many personal factors that affected what force it was going to take to break a human bone. I mean, the factors such as age, hereditary factors, bone density, what the diet was, and even external factors like temperature. Therefore, there was just too wide of a range in forces to align it with a specific level of protection. Said differently, it's near impossible to tell you with 100% assurance that a level 3 is never going to have a bone break underneath it. So we always recommend that you trial new PPE and to compare it to the performance of your existing, just to get a better understanding if you do need more protection. The ANSI ISEA gives you a great scaling system to be able to compare where you're at, and if you need more, how you can get to more. So as I promised, I would keep that short and sweet for you guys. I do have a few questions that I want to make sure I get answered. So let's jump to those. Is OSHA looking to tie any of this new standard into regulatory requirement? So not at this time. OSHA calls out in 1910 the general industry saying two things for hand protection. One, assess that if you need it, that you have it. And two, if you need it, that it's provided. So there is no call out specific to cut standards or impact or puncture, not even any sizing. It really is on the company's hands, on the safety manager's hands to decide what level of protection is necessary. And that's what ANSI ISEA ultimately tries to do is to provide you a scaling system to better understand that. Would your hand become hot, especially working outdoors during the summertime? Yes, possibly. So you're adding additional material on the back of hand, which could decrease some of that breathability. However, depending on how the impact material is adhered and if there's different break points in there, how much of the hand it covers, you're not necessarily going to be overheating. But I know personally, I'd rather have a hot and sweaty hand than a potentially broken hand from having no impact protection. Third question, can you provide impact protection without losing dexterity? Great question. So without going too far into this, it really has a lot to do with the durometer of the material. So the durometer is really the hardness, how hard or soft the material is on the back of hand. That plays a really key role in it. And also the design of the impact. Does it have break points? Or is it fully covering the hand? So it is 100% possible to provide impact protection without losing dexterity. You just have to look for the right materials. How will this be shown on the glove? Excuse me. So I am, if you can see my screen, I'm going to pop back and show you really quick just as a reminder. So on the EN388, it's going to show up as a pass or fail. It's the, a P for pass and F for fail, and it's the 6-digit under the EN388 symbol. Again, if you can see my screen, it's the upper right-hand corner, that 6-digit over. And that can be found on the glove, it can be found on the tag, as well as the marketing material. Just depends on how that manufacturer has it listed for the glove. For the ANSI ISEA 138, they don't require it to be necessarily on the glove, but again, it can be up to the manufacturer where it's located. You should be able to find it on the packaging or a sell sheet. If you can't find it, you can always ask the manufacturer as well. But that's going to be indicated by the hammer striking the hand icon, followed by a 1, 2, or 3. And again, if you can see my screen, it's going to be in the lower left-hand corner. Does weather affect the properties of the impact resistance? For example, if you're in sub-zero temperatures versus if you're in 90-degree Fahrenheit. Well, that really depends on the material of the impact resistance. So one thing to note is that your hand temperature will actually regulate the material temperature. So in both of the standards, the testing is being done in a 70-degree environment. With that being said, your hand is regulating the temperature to about that in an everyday application. So when you're going to extremes, such as that 90, 100, 115, or down on the opposite end, sub-zero, there will be some slight variation. But again, it really depends on what material is in that impact to determine how it's going to perform. For example, TPR is going to perform actually slightly better in colder temperatures, where a foam is going to perform slightly worse, and the opposite on the other end of the scale. So again, just talk with your manufacturers to better understand if that extreme temperature is going to affect the glove that you are looking to choose. Are there CSA standards that align? CSA is the Canadian Safety Association standards. So no, the ANSI ISEA is actually accepted as the North American standard. So Canada, United States, and Mexico all follow these ANSI ISEA standards. There's not something specifically in CSA, those standards that call out anything different. So I would assume that they're just falling in line with what these standards are. But just as a reminder that these are, guides and recommendations and not requirements. So is there a date for conformance? Typically, I'll just be honest, I'm not sure off the top of my head what that date is, but typically they have about 1 year to make the changes. That way it gives them time to send the product out for testing, update any marketing and packaging, etc. So typically we see all those shifts and changes in 1 year's time. Couple more questions coming in here. Will cut resistance be listed as well as impact? So if we look back to the EN 388, that CE score has those 6 digits. The second digit and the 5th digit are going to be cut. And then the 6th digit will be your impact. So in the EN 388, yes, cut resistance is also listed. For ANSI ISEA 138, they are listed separately, so you would have to identify those separately. Is there a shelf life for the standard? I'm not quite sure what you mean here. The shelf life as far as the impact material, or I'm going to guess that you mean the standard itself, i.e., if you're getting it tested this year, does it have to be retested next year? Let me know if that's not what you mean. So unless the materials change or there's an update or change to the standards procedures, you do not have to retest. So if the shelf life of the actual test results, again, unless the materials significantly change or the standard itself calls for an update, you do not have to retest. How will the new ANSI standard be enforced? Great question. So ANSI ISEA is an association that offers recommendations. So there is no government enforcement of specific standards. Specifically relating to hand standards, as we mentioned with OSHA, they simply call out that you need to provide a glove and provide a safe glove. So because ANSI ISEA isn't a requirement, there's no enforcement as far as making sure everyone tests to the standard. However, as I mentioned earlier, if they are testing to the ANSI ISEA 138, because it's being done by and required by a third party instead of internal testing, there is an enforcement to make sure that people are abiding by the standard specifications for how that test is done. So to actually have it tested is not required, but when they do get the testing, there is an enforcement of that's being followed through and tested accurately. Tell me about competitors. Do they have any problems passing the standards? And who are they? Haha, I will not throw any of our competitors under the bus because there was 25 of us that worked together to make sure that we were making a standard that was good for the people, that was good for the end users. But one thing that you're going to find is that a lot of products out on the market that were previously noted as impact products, with this new standard and how difficult it was to pass the different levels, there's a lot of products that will only be at that level 1. And if not, they're scrambling to find new materials to put on their back of hand so that they can update the material so that they can at least hit that level 1. We're lucky enough to have had all of our products already tested. Our products, for the most part, are in a level 1 and level 2, and we do have products in the level 3. Now, it's not to say that there isn't some competitors out there who also have things in level 2 and level 3. There's some fantastic products out there as well. This scaling system is just meant to help you identify if something isn't absorbing that energy, and then if it is absorbing that energy, how much is it? So, yes, there are some of our competitors that are not passing, but it's not to say within the next year that they're not going to improve their products so that they are passing. And then along the same lines, who are your major competitors and how do you compare? Again, kind of same thing. There's a lot of the competition for us and just in the industry in general. With safety gloves, you're going to see a lot of level 1 options because of the addition of the impact to the fingers. Now, be on the lookout for marketing that shows you what the impact is on the fingers and what it is on the back of hand. Because you may find that there are some products out there that have a level 1 on the fingers, but a level 2 or 3 on the back of hand, versus a level 1 on the fingers and a level 1 on the back of hand. So I would say that we really pride ourselves in being innovative. It was part of the reason why it was important for us. So HexArmor was one of the 25 manufacturers working on this standard to make sure that not only were we having our input be taken seriously for this standard, but then also trying to be ahead of the curve and making sure that we were providing products that our customers were going to need, and that our distributors would want to provide, to have multiple levels of options so that all of our gloves aren't hitting one category, that you do have that full range. And not every competitor is going to have that full range. Trying to keep this nice and tight for you guys. I haven't seen any other questions pop in here, but feel free to throw those in the question box or the chat box. And if there's nothing left for me, I just want to let you know that thank you so much for joining me today. I appreciate having you guys and all those questions. They were fantastic questions. You guys are going to receive a follow-up from this that's going to give you access into, like I mentioned, that handout. You're going to get a recording if you want to flip back to something. You can always respond back to that and shoot me a question or note. And I'm happy to answer that. Maybe something pops into your head later today or tomorrow or next week. I'd be happy to answer that for you. But if you just want to call in and talk to someone at HexArmor in general, you can always give us a call at 1-877-MY-ARMOR, or feel free to visit HexArmor.com. We have a learning center on there that was going to provide a lot of good content for you guys, as well as being able to look at our technologies and what have you. So if I have no other questions coming through, again, I'm going to thank you guys so much and hope you have a wonderful rest of your day. And we are going to sign off. Bye-bye, guys.